An alternating current, or AC, system constantly changes polarity. Because of this, measuring such a voltage or current is more complex than measuring direct current, or DC. When we say a voltage is 120 volts alternating current, it is implied that this is the root mean square, or RMS voltage. An RMS meter accurately measures the true voltage of a waveform, regardless of its shape. This is important for verifying the voltage supplied to appliances and ensuring they operate properly. Consider that a typical alternating current voltage follows a sinusoidal shape. An average responding meter makes assumptions about the shape of the voltage and may be inaccurate if the voltage is not purely sinusoidal. An RMS meter will still provide an accurate reading even if the voltage is distorted. One consideration is phase angle. Although the voltages in residential homes are typically sinusoidal, there may be slight phase angle shifts due to inductive loads or system imbalances. RMS meters can measure these phase angles, which can be important for troubleshooting electrical system issues. It is worth noting that phase angle is not typically a major concern in residential electrical work. Harmonics are another consideration. While harmonics are typically low in residential systems, RMS meters can detect their presence. This can be useful for identifying potential problems or disturbances caused by nonlinear loads such as electronic devices or variable speed drives. For example, some LED lighting and electronic devices can introduce harmonics into the electrical system. Transient response is also important. RMS meters can capture and measure voltage transients, which can be important for assessing the performance of electrical systems during sudden voltage changes or faults. For example, if there is a lightning strike nearby, it may cause a voltage transient in the electrical system. There are also some disadvantages to using an RMS meter. Firstly, RMS meters are generally more expensive than average responding meters. Secondly, RMS meters may be more complex to operate and interpret for non-electrical professionals. Overall, while an RMS meter is not strictly necessary for most residential home work, it can provide additional accuracy and insight into the electrical system. It is particularly beneficial for troubleshooting issues related to voltage quality, phase angle, harmonics, or transients. However, the cost and complexity should be considered before making a decision. The type of meter needed depends on the task and desired accuracy. An average responding meter will likely be adequate for many tasks. However, for accurate measurements of non-sinusoidal waveforms, an RMS meter is required. An RMS meter measures the effective or equivalent DC value of an AC voltage or current. It provides a more accurate measurement than an average responding meter when dealing with non-sinusoidal waveforms, which are common in modern electronic devices and systems. The presence of harmonics, which are multiples of the fundamental frequency, can distort the waveform and lead to inaccurate readings if an average responding meter is used. An RMS meter, on the other hand, calculates the true RMS value, taking into account the harmonics and providing a more accurate representation of the voltage or current. While it's true that residential electrical systems typically have relatively low levels of harmonic distortion compared to industrial or commercial settings, there are still situations where an RMS meter can be beneficial. For example, if there are a lot of electronic devices in the home, such as computers, televisions, and LED lighting, they can generate harmonics that distort the waveform. In these cases, an RMS meter will provide a more accurate measurement of the voltage and current. Another reason to use an RMS meter is for troubleshooting. If there are problems with the electrical system, such as flickering lights or equipment malfunctions, an RMS meter can help identify the source of the problem by measuring the voltage and current waveforms. If the waveform is distorted, it could indicate a problem with the wiring, the equipment, or the power supply. As for the phase angle, it's not typically a major concern in residential electrical systems. However, there are some situations where it can be important. For example, if there are large inductive loads in the home, such as motors or transformers, they can cause a phase shift between the voltage and current. This can lead to power factor problems, which can increase energy consumption and reduce the efficiency of the electrical system. An RMS meter can measure the phase angle between the voltage and current, which can help identify and correct power factor problems. It is important to understand the difference between average responding meters and true RMS meters. Average responding meters are designed to accurately measure pure sine waves, which is the type of waveform typically found in residential power systems. However, these meters can be inaccurate when measuring non-sinusoidal waveforms, such as those containing harmonics. True RMS meters, on the other hand, are designed to accurately measure both sinusoidal and non-sinusoidal waveforms. They use a more complex algorithm to calculate the RMS value of the waveform, which takes into account the harmonics and provides a more accurate reading. True RMS meters are particularly useful for measuring the voltage and current of electronic devices, which often produce non-sinusoidal waveforms. They are also useful for troubleshooting electrical problems, as they can help identify the source of the problem by measuring the waveform distortion. It is worth noting that true RMS meters are typically more expensive than average responding meters. However, the extra cost is often worth it for the increased accuracy and versatility. When choosing a multimeter, it is important to consider the type of measurements that will be made. If the meter will be used primarily for measuring voltage and current in residential power systems, an average responding meter may be sufficient. However, if the meter will be used for measuring voltage and current in electronic devices or for troubleshooting electrical problems, a true RMS meter is recommended. In addition to the type of meter, it is also important to consider the accuracy of the meter. The accuracy of a multimeter is typically expressed as a percentage of the reading, plus a number of digits. For example, a multimeter with an accuracy of plus or minus 0.5% plus 2 digits will have an accuracy of plus or minus 0.5% of the reading, plus or minus 2 digits on the least significant digit. The higher the accuracy of the meter, the more accurate the measurements will be. The choice of whether to use an RMS meter for residential electrical work depends on the specific needs and applications. While not always essential, an RMS meter offers several advantages that can be beneficial in certain situations. Firstly, RMS meters provide more accurate voltage measurements, particularly when dealing with non-sinusoidal waveforms. This is important because modern electronic devices and appliances often introduce harmonics into the electrical system, which can distort the voltage waveform. An RMS meter accurately measures the true effective voltage, taking into account the harmonics, while a standard average responding meter may provide inaccurate readings. Secondly, RMS meters can help detect and measure harmonics in the electrical system. Harmonics are multiples of the fundamental frequency of the AC power supply and can cause various problems, such as overheating of equipment, voltage distortion, and interference with electronic devices. By measuring the harmonic content of the voltage waveform, an RMS meter can help identify potential issues and ensure the proper functioning of electrical equipment. Thirdly, RMS meters can be useful for troubleshooting electrical problems. When diagnosing issues such as voltage drops, equipment malfunctions, or power quality problems, an RMS meter can provide valuable information about the voltage waveform and harmonic content. This can help pinpoint the source of the problem and guide the repair process. However, there are also some disadvantages to using an RMS meter for residential electrical work. Firstly, RMS meters are typically more expensive than standard average responding meters. This may be a barrier for some homeowners or electricians who are on a tight budget. Secondly, RMS meters can be more complex to use than standard meters. They often have more features and settings which can be confusing for those who are not familiar with electrical measurements. Thirdly, in many residential electrical applications, a voltage waveform is relatively clean and free of harmonics. In these cases, a standard average responding meter may provide sufficient accuracy for most measurements. Therefore, the decision of whether to use an RMS meter for residential electrical work depends on the specific needs and priorities of the user. If accuracy and the ability to measure harmonics are important, an RMS meter is a worthwhile investment. However, if cost and simplicity are more important, a standard average responding meter may be sufficient. It's also worth noting that some modern multimeters offer both average responding and RMS measurement capabilities in a single device. This can provide the best of both worlds, allowing the user to choose the appropriate measurement mode for each application. Ultimately, the choice of meter depends on the individual's needs and preferences. However, understanding the benefits and limitations of each type of meter is essential for making informed decisions and ensuring accurate electrical measurements. One important aspect to consider when choosing an RMS meter is its crest factor. The crest factor is the ratio of the peak value of a waveform to its RMS value. A pure sine wave has a crest factor of approximately 1.414. However, waveforms with high harmonic content can have much higher crest factors. An RMS meter with a low crest factor rating may not be able to accurately measure waveforms with high harmonic content. Therefore, it is important to choose an RMS meter with a crest factor rating that is appropriate for the types of waveforms that will be measured. Another important consideration is the meter's bandwidth. The bandwidth of an RMS meter is the range of frequencies that it can accurately measure. Harmonics can have frequencies that are much higher than the fundamental frequency of the AC power supply. Therefore, it is important to choose an RMS meter with a bandwidth that is wide enough to capture the harmonics of interest. In addition to crest factor and bandwidth, there are other factors to consider when choosing an RMS meter, such as accuracy, resolution, and features. Accuracy is the degree to which the meter's reading matches the true value of the quantity being measured. Resolution is the smallest change in the quantity being measured that the meter can detect. Features can include things like data logging, frequency measurement, and capacitance measurement. Ultimately, a best RMS meter for a particular application will depend on the specific requirements of that application. However, by considering the factors discussed above, it is possible to choose an RMS meter that will provide accurate and reliable measurements. Now, considering the initial question about phase angle, it's true that phase angle shifts can occur in residential homes due to inductive loads or system imbalances. While an RMS meter can measure voltage accurately regardless of phase angle, the phase angle itself is typically measured using a different instrument, such as a power quality analyzer or an oscilloscope. These instruments can display the voltage and current waveforms and allow you to determine the phase difference between them. In summary, while an RMS meter is a valuable tool for accurately measuring voltage and current, particularly in the presence of harmonics, it doesn't directly measure phase angle. Other specialized instruments are used for that purpose.